Hi everyone, now we are going to graph the sine and cosine functions using the skills and the steps that I showed you on the in the last video and on the last page. So here we go. The first thing we want to do is we want to graph y is equal to 3 times the cosine of x. So the first thing I'm going to do is I'm going to identify what the amplitude is. And the amplitude in this case is going to be the number that's in front of cosine of x, and that is the number 3. So our amplitude is 3. This amplitude represents our maximum value, and -3 will represent our minimum value. Our period in this case, well, since our b value is the number 1, our period is going to be 2 pi divided by 1. And 2 pi divided by 1 is equal to 2 pi. So our period is the exact same as the parent function. That means it will complete one cycle in 2 pi. The axis, because we're not adding anything yet, is going to be y equals 0. So for this lesson, I strongly recommend that you have out a highlighter of some kind, and you will absolutely need a straight edge. So make sure that you have both of those for this lesson. I forgot to mention that at the very, very beginning, but it's pretty close enough to the beginning. So here we go. All right, so now, what I would like you guys to do is we're going to come up with our table of values. And when it comes to our table of values, since this is cosine, I know that cosine always starts at where x is equal to 0, and it's up 0, down 0, up. So up means it's going to start at its maximum value, and the maximum value in this case is going to be 3. And you get that number from your amplitude, so it's going to be 0, 3. And then my x values in this case is going to be 1/4 times my period. So that's going to be 1/4 times 2 pi. Then I have 1/2 times 2 pi. Then I have 3/4 times 2 pi. And then 1 times 2 pi. So a fourth of 2 pi is pi over 2. Half of 2 pi is pi. 3/4 of 2 pi is 3 pi over 2. And is 3/4 or 3 pi over 2, and then 1 times 2 pi is 2 pi. So it's going to have the exact same x values as our parent function. Now cosine, like I said, goes up 0, down 0, up. So up at 3, then 0, then down to -3, then back to 0, then up again at 3. So now that I have my ordered pairs, that's what I'm going to plot. So I'm going to start off at 0, 3. And then I'm going to go to pi over 2, and I know that it's kind of small, but every single tick mark represents a pi over 4. So I'm going to skip a line and go to pi over 2, 0. Then I'm going to go to pi -3, then 3 pi over 2, 0, and then 2 pi up to 3. And I'm going to repeat this pattern going on the other side. So I'm going to go back down, down, up, and then back up again to 3. When you draw your graph, make sure that you pay attention to your end behavior. And also, it's very, very easy to make these graphs kind of look like zigzags with sharp edges. Please don't do that. If they look too zigzaggy and not like a smooth wave or curve, I'll mark you off for that. So just be very, very careful. The last thing I'm going to do is I'm going to use my marker to plot the axes, and that's going to be located at y equals 0. All right, so that is the first example. That's example number 2. After I go through all of the first examples, going through the notes, then what I want you to do is complete all of the b's as your turns. So I want you to do y equals 5 times the sine of x on your own. But that's going to be at the very end after I've shown you how to do all of the problems. So now we're on to example number 3. So for example number 3, we have y is equal to sine times 3x. So it's y equals sine times 3x. Our amplitude in this case is going to be an invisible 1, so that's the number 1. Our period is going to be 2 pi divided by our b value, and our b value in this case is 3, so 2 pi divided by 3. So that's our period, 2 pi divided by 3. There's nothing for us to simplify. And then our axis is going to be y equals 0. Since this is a sine wave, we're going to start at 0, 0. I'm sorry, yeah, we're going to start at 0, 0. Then all of our x values, I'm going to multiply 1/4, 1/2, 3/4, and 1 times the period. So that's going to be 1/4 times 2 pi over 3, 1/2 times 2 pi over 3, 3/4 times 2 pi over 3, and then 1 times 2 pi over 3. So that's going to be 2 pi over 3. And then I have 1/4 times 2 pi over 3. So that's going to be 2 pi over 12. So that's going to be pi over 6. And 1/2 of 2 pi over 3, the 2's would cancel out, and I'll be left with pi over 3. 3 times 2 is 6. 6 divided by 12 is pi over 2. And then we have 2 pi's over 3. So now I'm going to come up with my y values. My y values for sine always go 0 up, 0 down, 0. So I'm going to go 0 up to my maximum value, which is my amplitude. So 0 up to 1, then back to 0, then down to -1, and then back up to 0. So 0 up, 0 down, 0. Now when it comes to graphs like these, what I would recommend that you do is that you use a straight edge and count 6 lines in vertically. So I'm going to count 6 lines in vertically. 1, 2, 3, 4, 5, 6. And here is my vertical axis. And then I'm going to count 5 up, and that's going to represent my horizontal axes. So I have 1, 2, 3, 4, 5. Next, I need to label my graph appropriately. So for this type of problem, my maximum value is 1. So you can make your axes, your y-axis, you can make it go up to little 1, or you can skip a line. I'm going to skip a line just so that you guys can see the full wave. So that's going to be 1, and I'm going to skip a line down here and make this -1. Then I'm going to use my scale right here. It looks like I'm starting at pi over 6. So I'm going to make, I'm going to skip a line and make this pi over 6. Then I'm going to skip a line and make this pi over 3. Then I'm going to skip a line and make this pi over 2. And then I'm going to skip a line and make this 2 pi over 3. So what we have here is 1 pi over 6, 2 pi over 6, 3 pi over 6. 3 over 6 is 1/2. This is 4 pi over 6. So skipping a line, this is going to be 5 pi over 6. And then the next one's 6 pi over 6, which is pi. And then going backwards, I'm just going to repeat what I see right here going negative. So it's going to kind of be a reflection. So this is going to be negative pi over 6. Skipping a line, this is negative pi over 3. Skipping a line, this is negative pi over 2. And that's how you label your axes appropriately. Labeling your axes is going to be worth a solid point onto your graph. So please make sure that you graph each of these correctly and appropriately. All right, so now I'm going to plot 0, 0, and then I'm going to go up to pi over 6, 1, then back to 0 at pi over 3. Then I'm going to go down to -1 at pi over 2. Up here at 2 pi over 3, back up to 0. And then I'm going to go back up to 1 at 5 pi over 6. And then down to 0 at pi. And then I'm going to repeat this process, repeat this pattern going backwards. Now that I have all of my points plotted, I'm going to draw a smooth curve going through all of my points. Making sure my end behavior is appropriate. Then I'm going to take out my highlighter and draw in my axes. Axes are always dashed. All right, I'm going to now flip the page, and like I said to you guys before, the B's are going to be your turns. So, flipping the page, I'm going to go ahead and show you guys example number 4. For example number 4, we're going to have both an A value and a B value for these problems. So, my amplitude in this case is going to be 1/4. My period, I'm going to take 2 pi and I'm going to divide it by the b value, which is pi. The pi's cancel out and we're left with 2. So our period in this case is 2. And our axis is going to be y equals 0. So because this is one of those graphs in which you have to plot it yourself, like I said to you before, count in 6. 1, 2, 3, 4, 5, 6. And this is going to represent your vertical axes. And then I'm going to count up 5, and that's going to be my horizontal axes. 1, 2, 3, 4, 5. Okay, so let's come up with our table of values. So since this is sine, I know that I'm going to be starting at 0, 0. So then I'm going to work with my period, and I'm going to go 1/4 times 2, 1/2 times 2, 3/4 times 2, and then 1 times 2. So 1/4 times 2, a fourth of 2 is 1/2, half of 2 is 1, 3/4 of 2 is 1.5, and 1 times 2 is 2. So those are my x values, and my y values are going to be based on my amplitude. So that's 0 up, I'm going to go up to 1/4, 0 down to -1/4, and then back to 0. All right, so since my amplitude is 1/4 and I want to make it kind of look nice, what I'm thinking is that I'm going to make like every line maybe a fourth. So I'll make this 1/4, 1/2, 3/4, and then 1 whole. So I'll make this line right here 1/4. And then I'll make this line right here -1/4. 1/2, 3/4, 1. So this is -1 right here. Okay. Then for my x values, I have 0, 1/2, 1, 1.5, 2. So what I'm thinking is that I'm going to make every line a 1/2. So I'll make this 1/2, 1, 1.5. This is 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, and then 6. And I'm going to repeat it, -1/2, -1, -1.5, -2, -2.5, -3. You could also skip a line and make every other line 1/2, your choice. And you'll see that in a couple of the other problems that I have done for your turns, that you kind of you can make your scale whatever you want, essentially, as long as you are consistent. That's the most important thing. So you could do what I did right here. You could expand it, you could make it thinner, your choice, as long as you are consistent. Okay, so I'm going to plot 0, 0. And I'm going to go to 1/2, 1/4, then 1, 0, then 1.5, -1/4, then back up to 0. And I'm going to continue this pattern going all the way throughout. On both sides. And here's what our graph looks like. And now I'm going to go ahead and draw in my axes. And I'm finished with this graph. Last example is example number 5, before I have you guys work on the your turns. So here is example number 5, and in example number 5, we have y is equal to 2 times the cosine of pi times x. And so the first thing we're going to do is identify our amplitude. Our amplitude is 2. And then our period, since our b value is pi, I'm going to go 2 pi divided by pi, and that is equal to 2. So our period is equal to 2. And our axis is y equals 0. So now from here, I'm going to Since we're talking about cosine, our x value starts off at 0, and it's going to be 0 up. So 0, 2. We're going to go up to 2. So that's my first ordered pair. Then my rest of my x values, that's going to be 1/4 times my period. So 1/4 times 2, 1/2 times 2, 3/4 times 2, and then 1 times 2. Unfortunately, we just did that in the last example, so that's going to be 1/2, 1, 1.5, and then 2. And then for cosine, we're going to go up 0, down 0, up. So that's up to 2, 0, down to -2, 0, then back up to 2. And I'm going to go ahead and create my axes just like I did before. I'm going to count in 6. 1, 2, 3, 4, 5, 6. And here's my vertical axes. And then I'm going to count up 5. 1, 2, 3, 4, 5. And here's my horizontal axes. I'm going to use the same, I'm going to use a different scale this time. Instead of making each one go by 1/2, I think that I'll skip a line and make it 1/2, because you can. As long as you're consistent, you can do whatever you want. So this is going to be 1/2. I'm going to skip a line. This is going to be 1. Skipping a line, this is going to be 1.5. Skipping a line, this is going to be 2. Then this is going to be 2.5, and then 3. Here's negative 1/2. -1, and over here is -1.5, and then my y values, I'm going to go up to 2, so I'm going to make, I'll just go by 1, so I'll make this 2 and -2. That's what I'm going to do this time. All right, so now I'm going to plot my points. I have 0, 2, and then 1/2, 0, and then 1, -2, 1.5, 0, and then 2, 2. And then I'm going to continue by repeating this pattern. And then connect my points with a smooth curve. And finally, I'm going to draw my axes. All right, so now what I would like you guys to please do is I want you to please pause the video, and I would like you to do all letter B's on both sides of the set of notes. So I want you to do all letter B's. When you have finished with all letter B's, I'm going to show you what the answer should be. If you find that you have an error or something to that effect, and you're not sure about what error you made, make sure you have a conversation with me the next time I see you. If you find that you have the answer correct, awesome. So what I'm going to do is I'm simply going to show you what the answer is. I'll leave it up there for a few seconds so that you can genuinely see and check your answers to see if you got it right. But I'm going to be expecting that you're going to have all examples finished by the time I check in your notes. So I just want you to know that. So go ahead and pause the video. And then as soon as you're done with all of the letter B's, we have 2 more examples, and then we are done with this lesson. All right, let's go ahead and see how you did. So here is the first letter B. Y equals 5 times the sine of x. Here's the next letter B. I skipped every other line and made this 1/2, 1, 1.5, 2, 2.5, 3. And I skipped a line and made this 1 and -1. That was the scale that I chose to use. Okay. Let's check out example number 4's letter B. If y equals 3 times the cosine of 4x. I choose to go by a scale of every other one is a pi over 8. and I went by ones to make that 3 and negative 3. And then finally our last letter B. We have y is equal to 5 halves times the sine of 2x. I chose to make every other line a pi over 4. And what I did is I went by ones and I just kind of approximated where 5½ would be and negative 5½. So hopefully you got all of those correct. We have 2 more examples and then we are finished with this lesson. All right, so here's example number 6. Example number 6 says, write a sine function with an amplitude of 3 and a period of 1,000. Okay, so if we're writing a sine function, that means that we're talking about y is equal to a times the sine of bx. So remember that, that your a value, we can tell right away what our a value is going to be. It's going to be equal to 3. But then we're given frequency. So now here's a little formula for you. Frequency is the reciprocal of period. So frequency is equal to 1 divided by your period. So it is, in other words, your frequency is equal to, since period is equal to 2 pi over b, your frequency is equal to b divided by 2 pi. That's what frequency is equal to. So what I'm going to do is I'm going to identify what my b value is by setting frequency equal to b over 2 pi. So since our frequency is equal to 1,000, I'm going to set it equal to b divided by 2 pi. I'm going to make that over 1. And I'm going to use cross product. And when I do that, I end up with b is equal to 2 times 1,000, which is 2,000 pi. And that's just going to be an exact value. So b is equal to 2,000 pi. So my equation is going to be y is equal to 3 times the sine of 2,000 pi times x. And that is my answer. So once again, frequency is equal to the reciprocal of pi. So that's the reason why I have that written there. All right, now let's go ahead and look at example number 7. For example number 7, it says a sound consisting of a single frequency is called a pure tone. An audiometer produces pure tones to test a person's auditory functions. Suppose an audiometer produces a pure tone with a frequency f of 2,000 hertz, which is cycles per second. The maximum pressure from the pure tone is 2 millipascals. We want to write a sine model that gives pressure as a function of time in seconds. So we know what our normal function should be. Y is equal to a times the sine of b times x. And so we want to give pressure as a function of time. So that means that p is going to be our y value. We're still going to have a times the sine of bx, but instead of bx, it's going to be b times t. So we're just replacing y with p and x with the letter t. And we have ourselves a max pressure. So a maximum means that in this case, a is equal to 2. So that's our maximum. And we are given frequency. Our frequency, remember that is equal to the reciprocal of a period. That's 1 divided by period. So if period is equal to 2 pi over b, the reciprocal is going to be b over 2 pi. So our frequency is going to be equal to b divided by 2 pi. And if our frequency is 2,000, that's going to be 2,000 is equal to b divided by 2 pi. I'm going to make 2,000 over 1 and use cross product, and we find that b is equal to 4,000 pi. So now that we have our A value and our B value, I'm going to write that P is equal to 2 times the sine of 4,000 pi times T. And that is our function. That is our answer. This is the end of today's lesson. If you have any questions over anything when it comes to graphing sine and cosine waves, please make sure that you let me know. Otherwise, I will see you tomorrow.